In this video we're gonna find a quadratic equation for given graphs. First of all, we are given actually parabolas, and our basic parabola or basic function equals y equals x squared. Yes. Now to see what's happening with our graph, we just first of all I think we have to graph our basic parabola, which actually you can use just points, because for the basic parabola its points are 0, 0, and if you plug in 1 for the x, it will be output is 1. It means around from these points. And now what happened difference between this graph and this? It's actually moved to the right by 1, 2, 3 units. It means how we're moving graph to the horizontally to the right. We're just subtracting from input 3 units. And if our input was x, now for our input, this box, we're subtracting 3. It means now x minus 3, we chose our input, and it's squared. And that's it. This is our new formula or quadratic equation. How you can see, actually this is a vertex form. Vertex form of quadratic equation. It means actually if you know the vertex form, general vertex form is looks like a x minus h squared plus k, where a represents a stretch and a reflection because depends on the sign, h represents shift to the horizontal shift, and k vertical shift. In this case, if we know our vertex and our stretch, we can plug into this formula and find the equation right away. And now let's check how it works. Actually, our point or vertex is 0, 3. Actually opposite, 3, 0, because x value y 0. Okay, and what we do, we just check the shift, check our stretch. Our stretch is actually, it's not stretched because for the 1 unit we have 1 unit up for the first one. It means this one is 1 because it's the same. H is actually horizontal 3. It means 1 x minus 3 squared, and k is actually 0 because it's on the same y value, and it is equals x minus 3 squared. It's actually the same what we get. You can just this form will be useful a little bit later when our graphs are more complicated. And now to check if our answer is right, let's graph it on calculator, and using y, and our function x minus 3 squared, x minus 3, or everything squared. Graph it. Okay, now it's actually you cannot see anything, but we have to change window for a given one. -1, 6. Okay, go to window and changing -1, 6, 1, -2, 6, 1. Graph, and boom, it is actually the same what we have. Move to 1, 2, 3 units to the right. Okay, next one. Oops. Next one, this graph. Again, if you use the vertex form, just plug in, find the vertex, which is boom, 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 -2, and right here, which is -1, -2, -3, and our vertex is -2, -3. What does this mean? Plug in where we have x minus h is -2, minus 2 squared, and plus k is -3, minus 3. Now let's find if we have stretch, and if we plug 0, 0, it's okay, but if we plug in 0.1 unit for the basic not stretched, it should go up by 1 unit, and it is actually. it means our a equals just 1. Now let's simplify it. We have x minus 2, it will be x plus 2 squared, plus minus 3 is minus 3, and this is our vertex form of our quadratic equation. And if we plug into our calculator, x plus 2 squared, okay, y, and equal, open parenthesis, x plus 2 squared minus 3, graph it. Okay, we can see on the side. Now again we should change to our window, given one, window, -5, 2, scale 1, -4, 3, scale 1, graph. And it is the same graph. Move left 1, 2 units, move down 1, 2, 3. Okay, and next one. Again, to change to general, actually I forgot to tell you that changing to general form, you just have to simplify this expression. It will be general form of the quadratic equation. Next function we have right here, and again let's check our vertex, and our vertex is 1, 2, 3, 4, 4, 4, 0, 4, 0. Okay, if we have 0.40 for the vertex, and our basic formula is x minus our horizontal shift, which is 4 squared, plus our vertical shift, which is 0. Now what is our a coefficient? And our coefficient, first of all, we're checking the stretch. Remember, for the 1 unit should be 1 output, only for the first one. We have 1 unit, and it's only 1 out, 1 down. It means it's still 1, but now it's on up. It's reflected across the y-axis, across the x-axis. To reflect it, we have to change the sign. Okay, and now what we have negative. We don't have to write 1. It means negative x minus 4 squared, and this is our vertex form, vertex representation of our quadratic function. And let's graph again. Let's change window right away. Window, which is -1, 7, 1, -5, 2, 1, and our function going to y, and is our function negative, open parenthesis, x minus 4 squared. Graph it, and it is exactly the same. Down 1, 2, 3, 4, vertex on 0, 4, 4, 0, sorry. Okay, and now next function. Next function again, just check the vertex. The point is 1, 2, 3, and x value is -2, y value is 3. Means our vertex is -2, 3. Again, okay, let's leave some space for the a value, and x minus our shift, which is -2 minus 2 squared, plus our vertical shift, which is 3. Now what is our a value right here? It's reflected. If it's going down, it means we should put negative sign and check if our graph is stretched. When you go 1 unit from the vertex, it should be 1 change of 1 in output, and it is actually. It means our graph wasn't stretched or compressed. Plug 1, simplify, and we don't have to write 1, negative x plus minus 2 is +2 squared plus 3, and this is our vertex representation, vertex form of quadratic equation. And again, just graph. Okay, y, and we go, oops, clear, minus, open parenthesis, x plus 2 squared plus 3. Graph it. Again, our window should be -5 to 1, -4, 4, 1. Graph, and we have exactly the same graph. We moved left 1, 2, moved up 1, 2, 3. That's it.